So we're looking at this new interactive PLS path modeling application. Runs in a web page developed in R using the Shiny package. One means of input is using a smart PLS model. So let's go to another example here, a data I collected in Second Life. It was a research on purchasing behavior in Second Life. The model looks like this. And so we're going to demonstrate particularly being able to estimate group differences, MGA, multiple group analysis, using both the permutation and the parametric approach that is embedded in the PLS-PM package. Okay, so there's our model, and we save it. You don't have to have smart PLS input, but that's one quick way to do it. And it's a very popular tool, smart PLS, so probably a lot of people will like that feature. So we go over there, and first the data. That's where you always start. There's our data. Only 237 records in this one. It's a smaller data set. And we'll load in the smart PLS file to begin with, which is this one. And we immediately have all of our reports because we did not bootstrap. Okay, and we have same thing. This plot might take just a second to show up. There they are. Sometimes you have to click a couple of times to remind it that you're waiting. Here's one we didn't look at before, hierarchical cluster analysis of the latent variable scores. It shows the individual record identifier. I showed you it with this one because we only have 237 records. If you have 1,000 records, it's illegible. But you can see the grouping, the clustering. This is a dendrogram from a Ward's technique for cluster analysis. And it depends on what height you want to cut off this tree here, but you can take note of the grouping of the latent variables, and they should, because they should be distinct. So it looks like probably down here we have, well, 1, 2, 3, 4, 5 different groupings, and even, let's see, we have 7 latent variables, so ultimately you'll find 7 groupings, but this is a useful technique. So let's go on. Let's look at the group differences, and you can do that right now. The group differences for permutation, the two reports, there's permutation and parametric, are empty because we haven't turned it on. If we say we want to run group comparison test, note you can't see all the controls until you need to. If we say yes, we want to run a group comparison test, then we get a pop-up box. It's asking us to choose one of the variables in that data set. It must be a factor that has 2 levels, and it's telling me that the one it was pointing to, subject, did not. This is it here, experience. So we say take that, and notice it immediately reacts. And it'll take a second here to do this because it has to bootstrap it using the default 100. This routine has its own bootstrapping. Well, it wasn't that long at all. Okay, so here's the parametric. Parametric is faster than permutation. Permutation's still computing. This uses, I believe, pooled standard errors to estimate the t-test. And we see 2 of the path coefficients are in the 2 groups, experienced and not experienced, I should have explained that, are different in the structural model. The one from enjoyment to attitude, this one, and the one from trust to attitude, this one. Note group differences. There's an interaction or moderation effect. However, using a parametric approach makes assumptions about the distributions that really we usually dismiss with PLS. So you're probably better off looking at a permutation approach. So here are the results of that. This is not actually pure permutation. This is, I believe, the Satterwhite. It's a more generalized approach. It's still bootstrap, but they're using a t-statistic. I'm going to endow this with a pure permutation approach, which is really the best way to do this. Just uses probabilities. We'll talk about that when I get the feature in. Okay, so we see here the estimate's a little different, only this one path from enjoyment to attitude, the permutation approach noted that was different. Okay, and again, you can download all of these reports. This is group differences permutation, so we grab that and hit the download results button, and we will save it, and we'll come right back to take a look at it. And so that report looks like this. And you, of course, you can do whatever you want with Excel. Okay, so what else can we do here? Well, we can also load in the measuring items, the measuring file separately. Turn this off. Note all the reports go blank because we're missing information now. Here's the measure file. Here's the structure file. Get those in there since I'm not using SmartPLS anymore. It will recompute the group differences. It's bootstrapping it because there is a bootstrap in that routine. The other reports, however, are ready right now, as are the plots. There's the permutation report. Those two files, the measure file and structure file, let me show you those. Here's the structure file. It's really very simple. All you need to do is enter, this is the structural model, enter in a from to matrix. From to. What does that mean? Here's the structural model, the inside model. Note the direction of the arrows. So we have an arrow from ease of use to perceived usefulness. We have an arrow from perceived social presence to perceived usefulness. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inner paths. You tell the computer where they are by simply listing where the arrow starts here and where it goes here. So for the structural model, just 10 rows with from latent variable this one to this latent variable. That's all there is to it. You can input any model doing this, a new model, one of your models. And then the measurement item, it looks like this. It's the same thing, from to. And if it's formative, you just will reverse them from to. What does that mean? Well, if we go back to SmartPLS, so ease of use goes to each one of these measurement items. PSP goes to each one of these measurement items. You just simply put in two columns. Here are the measurement items, PSP 1, 2, 3. PSP starts at PSP, the latent variable, ends at PSP 1 measurement item. Starts at PSP latent variable, ends PSP 2 measurement item. That's all there is to it. This is the measurement from to matrix, from these latent variables to these measurement items, because these are all reflective. And then here's the structural model. From these latent variables to these. You don't have to have a SmartPLS model to do this. You can input by this means exclusively. Well, that's pretty much a quick look at my tool. It will be one component of many. I'm working on Super Bootstrapper. All of these components will integrate. Then I will have a multivariate analysis component, which will enable you to do detailed cluster analysis, exploratory factor analysis, very likely discriminant analysis, and perhaps confirmatory factor analysis as well. A very useful adjunctive type multivariate analyses go hand in hand with both PLS path modeling and structural equation modeling. And then of course, we'll get into the structural equation modeling world as well. Between PLS path modeling, super bootstrapping, and multivariate analysis, those three tools together will be very powerful in terms of comprehensive analysis of your multivariate data for any sort of PLS path modeling requirement. Thank you so much for taking the time to view this. I hope you find it useful for your purposes.